we've been graphing functions involving sine and cosine, and I wanted to take this opportunity to run through problem 4 on a recent assignment we had. In this case, our job is to fill in these blanks that help us get set up with important values from this function, and then try and draw a picture of this thing on the graph that's provided. So what we do is we run through and we look for the amplitude, which is this 3 in front of the sine function. Our period is 2 pi divided by k, and in this case k is 1/2, so our period is going to be 4 pi. Our vertical shift is the -1 there, so this is down 1. Our phase shift, this is going to be interesting, it's positive 2 pi over 3 divided by 1/2. So that is 4 pi over 3 when you do the arithmetic on that. To get the highest line, the max line, it's our vertical shift, -1 plus 3, so that's +2. And our minimum line is vertical shift, -1 minus 3, which is -4. Once you have the numbers filled in, the next step is to draw our 3 guidelines in. We start with that midline, which is at the vertical shift. So what's normally the x-axis moves down to -1. And so now we're at -1. And then our max line, we've already computed to be at 2, so that's the highest this wave is going to hit, this periodic function. And down at -4, that's the lowest it's going to hit. We are so close to being done with this thing. The last piece, though, is one of the more challenging parts, and that is to figure out where to put the start and end dots so we can draw this sine function. Remember, in general, a sine function starts at the middle, goes up, back to the middle, halfway through, down, and then back to the middle at the end. And our strategy is to locate these 3 points and then draw in the shape. So, first of all, we have a phase shift of 4 pi over 3. Locating that 4 pi over 3 on this graph is not obvious because the graph is numbered by integers involving pi. So I happen to know that 4 pi over 3 is somewhere between pi and 3 pi over 2. And it's a little bit closer to 3 pi over 2. So my starting point's going to be there. And then we have a period of 4 pi. 4 pi is 8 of these squares, right? 1 pi is 2 squares, and 4 pi would be 8 of the squares. So essentially what I want to do is count 8 squares over from my blue dot and put the ending dot. So I'm basically going to go 1, and I'll kind of dot it out in green so you can see how I'm counting. 1 square, 2 squares, 3 squares, 4 squares, 5 squares, 6 squares, 7 squares, 8 squares. And it's going to end up about 4 pi over 3 away from 4 pi. So that's the length of one cycle. That means halfway between those two things, I'm going to come back to the middle again. And that midpoint is going to be 4 squares away. So 1, 2, 3, 4. So the midpoint of my shape is about right there. Oops, I hope you realize I've made a huge mistake in that I'm supposed to put all these on the midline. So I'm going to transfer them down and then see if it'll let me erase those. Yeah, we draw those sine points right on the midline because the sine function starts in the middle. And of course, it's not going to let me erase that, which is just weird. I'm going to pause and see if I can delete them. So I did successfully delete the dots, but now I have to put them in again. So that first dot was here, and then the last dot was here, and the middle dot is 1, 2, 3, 4. So it was right here. Okay, so these are the points that are important for the sine function. Halfway between the first 2 dots, which is probably about here, we're going to hit our max. And halfway between the last 2 dots, which is probably about here, we're going to hit our min. And then back here, we're going to hit our, how far is that? So that's right around Here we'll hit our min again, and then we won't hit it there. So the curve is going to look something like this. And nobody's drawing is going to be perfect, but that's the idea. And then just to let you know that the pattern is going to repeat, I'll stick arrows on the ends of these things, and we'll call it a day. Actually, I'm going to extend this one a little further. So this is a pretty good estimate of where this graph is going to be located using the information that we had available, which is we know the vertical shift, we know the amplitude. That's how we figure out the max and min lines. And then we have a phase shift to the right of 4 pi over 3, and our period is 4 pi. And using that information, we're able to sketch the graph of this function. It's not completely accurate, but it's pretty close. If you want to see the accurate graph of the function, you can type this into your favorite graphing software like Desmos or GeoGebra or a graphing calculator, and you can zero in on some of these points a little more accurately than what we've done. For our assignment, we're trying to get close. We're trying to use the information that we pull from this equation to make a pretty good graph for this thing. And if you've done that, then you're on the right track. I hope this helped, and I'll see you soon. If you have any questions, just let me know. Take care.